All right. Hello, everyone. Welcome, friends and colleagues, fellow MIT alums. It's my great pleasure to welcome you to the third webinar in the MIT Africa Lecture Series. My name is Tunde Fafunwa. I am a 1992 graduate of Course 1, Course 6, Course 15, and Course 17, which is a real testament to MIT's flexibility and collaboration. This webinar series is a collaboration between the MIT Alumni Association and MIT Misty Africa program, featuring lectures by 4 MIT faculty members discussing their ongoing research activities in Africa. It is a real first. This is an inaugural series. It's something that the MIT alumni in Africa had asked for, and it's a real great pleasure to be part of this and to be able to welcome you. The topics covered during this particular session and series includes the built environment and urban politics in Africa, which was held 2 weeks ago. Last week's lecture, which was Rethinking Nuclear Energy Solutions for the African Continent, and today's lecture, which I'm very happy to welcome you to, which is Collaborating on Space-Enabled Designs with African Leaders. The fourth in the series will be next week, and will cover MIT's engagement, MIT Africa's engagement in the 21st century, challenges and possibilities. Before we begin, a quick housekeeping note. We encourage you to submit your questions in the Q&A box, and we'll try and get to as many of them as possible during the Q&A session after the lecture. So it's my great pleasure to introduce today's speaker, Professor Danielle Wood. Professor Wood is the Director of Space-Enabled Research Group, an Assistant Professor of Media Arts and Science and Aeronautics and Astronautics Media Lab. Professor Wood leads the Space-Enabled Research Group, which seeks to advance justice in Earth's complex systems using designs enabled by space. Professor Wood is a scholar of societal development with a background that includes satellite design, earth science applications, science engineering, and technology policy. In her research, Professor Wood applies these skills to design innovation systems that harness space technology to address development challenges around the world. Prior to serving as faculty at MIT, Professor Wood held positions at NASA as well as elsewhere. Professor Wood earned her PhD in engineering systems, SM in aeronautics and astronautics, an SM in technology policy, and an SB in aerospace engineering, all from MIT. So without further ado, Professor Wood, over to you. Thank you.
Thank you so much, Tunde, and a big thank you to the MIT Alumni Association and to Misty Africa. It's wonderful to collaborate with each of you, and today to collaborate with both of you together. It's my great honor to be with all of you today, and I hope I can humbly share the invitations I've accepted to collaborate with space leaders all over Africa. I want to share that has been a bedrock to my career, which has been the hospitality of pioneers in the space industry across many parts of Africa. Today I can also note as background my own virtual background, which is a satellite image created by NASA of Mount Kilimanjaro. And I choose this image as my ongoing visual branding because it was a place close to this picture that I first was inspired in my career. I'll share a bit more about my early visits to Kenya as an undergraduate volunteer from Africa, in Africa from MIT, and how it inspired my work. So please just note with appreciation that view of Mount Kilimanjaro. As I get started, I'm excited to share with you how I work to design for sustainability on Earth and in space. In particular, today, I'd like to show how I do this in cooperation with leaders of African space agencies. And I hope that many of you are aware of the space agencies that are active, including the African Union level space agency. And I was hearing already from the MIT Alumni Association that some of our particular countries that have high representation of MIT alumni are also countries that are active in space, like South Africa, Ghana, Nigeria, Kenya, Egypt, Morocco. These are also places where I'm often learning about or learning from or being invited to visit. Let's cast our mind back to the beginning of the space era to set the scene. Many will comment in the space community that 1957 is a key moment where the first human object is purposefully launched into space by the Soviet Union. Sputnik was a major revolution in the question of how humans would relate to space. But of course, it was happening in the context of a much larger global context, including a period of the struggle for decolonization by many countries in Africa. And particularly in that same year, I just came back from a visit to the locations in Ghana where the celebration and the assertion of independence occurred just a few months before the launch of Sputnik. So I love thinking about this 1957 year where the space era is formally inaugurated with a launch to space, but so is an independence movement starting in Ghana and spreading to so many countries. And these newly formed countries were aware of the major technological changes, especially in the aerospace and nuclear communities. I think it's so fitting that we had these speaking back to back on nuclear topics and on the space industry, because they were both key questions of the era of independence. What should a government, any new government, be thinking about with regard to aerospace and atomic energy issues? In fact, the Ghanaian in particular, the Ghanaian government starts an Atomic Energy Commission, which later becomes the birthplace also of the Ghana Space Science Technology Institute, which I'll speak about later on. Of course, we can look at all the years for decolonization and then the wave of liberation movements that are happening, starting 57 and going forward all the way to the 70s. And I appreciate as well that these newly defined political boundaries also bring responsibility in the era of the United Nations. Many countries in Africa ask themselves how they'll participate in United Nations committees with these newly updated definitions of their government. Meanwhile, on the UN side, there's a response to what's happening in the space industry. 1967, just about 10 years after the launch of this first satellite, an important treaty is signed called the Outer Space Treaty, which, as you see, the major players on that first day are the USSR, the Soviet Union, the United Kingdom, and the United States, which does bespeak some benefit, at least, of diplomacy in the era of the Cold War, where there could be only negativity between these players, but we instead see both the Soviet Union and the US committing to peaceful cooperation in space, which does create an opportunity for global cooperation. One of the key lines in the Outer Space Treaty reads as follows: the exploration and use of outer space should be carried out for the benefit and in the interest of all countries, irrespective of their degree of economic or scientific development. Now, while an anti-colonial view of the statement could see actually some sense of patronizing, I think, in the terms, basically the US and the Soviet Union basically saying, well, these other countries that are newly independent, we're not sure if they're developed, but at least they can enjoy space. So I think we can certainly critique that. But I do appreciate the novelty of this newly formed treaty, highlighting that space is not only for the countries that are currently active, but for all countries to benefit from. And then I think what I've seen is countries in Africa making a strong effort to make this true for themselves. We can think about the committee which wrote the treaty. It's called the Committee on the Peaceful Uses of Outer Space. And you can see the membership growth starting in around 57, going all the way up to 2019. There's now over 100 countries that are members. They're from every region. So when I go to the committee as an advisor to the United States delegation, I'm always seeing my colleagues from African space agencies, Southeast Asian space agencies, Latin American as well. They meet in these meeting halls in Vienna, which are very traditional in the UN setting. And I'm often able to serve through a competitive process. I applied to work with the US delegation and to meet this international community who's dedicated to designing the policies and international dialogue that guide the peaceful cooperation in space, and in particular, trying to make it true what's in that treaty, that actually all countries should benefit from space. So I can give presentations about my work and highlight the principles that I think are important for sustainability and design. And again, throughout this room, I'm often greeted by my long-term colleagues that have been designing their own national space programs across Africa. But how did I get to this point where I have the privilege to go sit with the African space leaders in the United Nations meetings? I want to go back in my own story to highlight actually before the 2000s, in 1999. This is a picture of a NASA satellite launch that took place when I was 17 years old. I was in Florida, where I grew up, and had the great privilege to work as an intern at NASA. I just want to appreciate NASA's investment in education that gave me opportunities from high school till now to be involved. And I was inspired to watch this launch of a space shuttle carrying the Chandra X-ray Observatory, which I barely understood, but I knew it was going to be a telescope orbiting the Earth, receiving light in the X-ray part of the spectrum from distant locations in the universe that could give us an understanding of what happens at the edge of black holes. That was my basic understanding as a 17-year-old. But also I knew that there were two women who were astronauts on the mission. In particular, Eileen Collins was the first woman to lead a mission like this as the commander of a space shuttle mission. And I knew it was a very important venture that gave me both physical excitement just to see it launch, but also really inspired me with the international nature of the space teams that come together to make this kind of a mission possible. I decided to become an aerospace engineer, which helped me decide whether I should go to MIT or Harvard, because clearly MIT is the place to go to major in aeroastro, not Harvard. So I came to MIT. This is a picture of me as an undergrad. I was about to finish my first degree in aerospace engineering. I got involved with one of the UROP programs in Professor David Miller's Space Systems Laboratory. I was exposed to these robots called spheres. It gave me lots of really challenging opportunities. It also helped me get to grad school because that engineering experience was key to my grad school application. So I'm so thankful for that experience, and I, was committed indeed to being part of this overall international space community and to gain the skills, but I found it very challenging. Meanwhile, even as I was taking this journey to being inspired by NASA, to working on really interesting space missions that actually are involved with NASA at MIT, I had another piece of my work. As an undergrad, I also was inspired to be part of the diasporic community of people interested in what happened to Black women around the world. And I had an invitation to visit a school in Kenya as an undergrad. So after my first year, after my second year, and during my fourth year, I traveled to visit the same school. It was called in Swahili Chambo Cha Penda, and it was operated by an American nonprofit. And these days I feel like it would be even better to work with a locally run school. But I was thankful to be among a group of about 50 girls, ages about 5 to 18, and I spent time with them and just learned a lot about their experiences. You see us at a farm. We're in Oloitoktok in the southern part of Kenya, in an area called Amboseli, very close to Mount Kilimanjaro, which is why I always show that satellite view of Mount Kilimanjaro. And it was a time of me asking if I want to be a space engineer and design space systems like those Spheres robots that operate on the space station, how does that have any impact on the lives of girls like these who I share some sense of solidarity with? I know that they should have opportunities for education and for working to make their country better. And does me becoming a space engineer have any contribution to that? For some years, I felt frustrated, and I thought perhaps there was no opportunity to blend my space engineering work, maybe a NASA career, with thinking about the experiences that these girls were facing. I enjoyed so much time with them, learning songs and practicing language and just having fun and seeing them grow up a little bit. But I almost decided maybe I was in the wrong field because I thought, shouldn't I do work that had more direct connection? For example, my close colleague who also traveled with me to Kenya was a civil engineer, and she seemed to have skills in things like testing water quality and setting up infrastructure that seemed more relevant than my skills in space engineering. However, I fortunately started to learn over the years that there is a way to ask how to connect between my interest in space and the opportunities that people all over Africa were taking for themselves. And I've since now founded this organization called Space Enabled at MIT in the Media Lab, where we seek to advance justice in Earth's complex systems using designs enabled by space. And truly, I would say that I'm continuing to ask the same questions I asked as an undergrad. How can I be a part of showing solidarity with improving the lives of Black women around the world? And yet I've seen how I can do it through the tools of space engineering, and I want to share that with you today. And to be honest, it's possible because of the cooperation with African space leaders and of course many other leaders around the world that I've gotten to know. You can learn more about this example at my TED Talk. It's called 6 Space Technologies We Can Use to Improve Life on Earth. It's available online. And in the talk, I give some of that example of my experience in Kenya and how actually it was leaders in Kenya that I met that showed me how they were using space technology to help me understand how I could have this career path. I also highlight how we can apply satellite technology and other tools from space research to address the Sustainable Development Goals. And I can say I feel confident talking about them, particularly because many of the countries that invite me to work with them in Africa are also using these goals or something similar. Many use also the Agenda 2063 of the African Union to talk about how they are working in their national goals. For example, the National Statistics Agency of Ghana and Angola use these goals as part of their process of national accountability. And so with them, I also ask, how can we use satellite technology in your own methodologies for accounting for the goals? I'd like to offer that there's a recently published paper. It's freely available to anyone. It's called Challenges and Progress in Applying Space Technologies in Support of the Sustainable Development Goals. I've just published this a few weeks ago, and I'm really proud because it highlights about 5 years of my thinking on different aspects of the space industry and how each, in a different way, can support the SDGs, but also the changes that need to happen to make them even more reliable and useful. So my argument is that we as the space community need to redesign our space technology to be more useful to policymakers who are addressing what development means in their own communities. I can pause and just note, it's not that I want the United Nations definition of development to be the only option. Of course, I think locally defined definitions are the most important. But I think many countries have adopted the SDGs as a common framework that can be useful for summarizing some of these goals. I encourage you to check out the link. You can go online and look for this paper, and it should be freely available to you. The 6 technologies I highlight in my research include these: satellite Earth observation, satellite positioning and communication, space technology transfer, human spaceflight, and research infrastructure, including the fundamental research that happens when there's installations of major telescopes or other basic science infrastructure. Today I'll highlight in particular my ongoing work in the area of satellite Earth observation, which is where I have some direct cooperation, especially with the countries of Angola and Ghana and their national space programs. Over my longer career, I look forward to having examples of each of these, and if you ask for some of my follow-up work, I can share some of our ongoing work, especially in human spaceflight and microgravity research, as well as in thinking about the benefits of research infrastructure. But today we'll see especially examples from Earth observation. Part of the opportunity to work in this area is because of the innovation happening, especially in Africa, Latin America, the Middle East, in the early 2000s through today. A number of countries around the world want to be emerging space nations, meaning countries that have their first opportunity to operate their own national satellite as a way to increase their own sovereignty in the use of space technology for national goals, including agricultural management, disaster response, and responding to other environmental and management issues. So I've developed a concept of the Collaborative Satellite Development Project. I studied a number of examples in my doctoral thesis of how countries that partner with a more experienced space country to learn to build satellites locally. This is relevant in the space community because space technology is often held tightly by those who have experience, and it takes a lot of effort to learn this technology that involves distant technology. You operate a satellite and it's something that is gained through experience, but it's not something that can be easily reverse engineered unless you have involvement with a project. So countries like Nigeria and others around Africa, but also around the world, have done partnership opportunities to bring technology into their country so they can then build their own satellites locally. So this is the topic of my PhD thesis. Through that experience, I got to visit a number of countries. I spent time both inside and outside Nigeria learning from those who worked on the first satellites called Nigeria Sat 1, Nigeria Sat 2, Nigeria Sat X, a series of communication satellites. And I've seen the leaders of these programs both in their own facilities in Abuja as well as around the world at conferences. And I interviewed them about their experiences. Also in South Africa, in Kenya, and Ghana, I had a chance to learn a lot about their history and see how they developed their national space programs. And you see also a major private industry emerging. I just came back from a major conference called New Space Africa, which brought together both all the government space agencies from across Africa, the African Union, and many private sector organizations. I have close cooperation with the Angolan space program, and I'll share a bit more about that today. And I was so proud last year to host Dr. Zolana Joao as a guest speaker in my class. The class is called Space Technology for the Development Leader. Dr. Zolana Joao gave the talk describing his experience founding the Angolan space program and highlighting how he sees that as an important contribution within the country's development overall. That video is available online. I can share that with you later. So let's go back to these technologies, and as I mentioned, I'll emphasize today examples of using satellite Earth observation. I'll show how I cooperate with the Angolan space program and the Ghana Space Science Technology Institute to use these technologies as they've identified particular priority areas. Before I came to this current job, I worked for several years in the broader American space program, working for NASA and other organizations that support the US government. In NASA, I worked in their Earth Science division and learned a lot about this set of satellites that I'm showing here in animation. These are examples of some of the satellites NASA operates to orbit the Earth and take measurements of the Earth. And for those who are outside the satellite community, I'll highlight a few key points. You see different names. Each name is a specially customized satellite. The satellites are typically observing using infrared light as well as They can also take measurements in our visible spectrum, but they also can use microwave. What they can measure has to do with what light can transmit through the atmosphere. Some wavelengths translate well and some do not. And so we are noting that each satellite has a custom design, and typically they are operated for scientific research, not necessarily for operations, but many times we become dependent on that data. One of my contributions as a system engineer is a framework that I call EVDT. It stands for Environment, Vulnerability, Decision Making, and Technology. It's a framework talking about how we can transfer the raw scientific data coming out of those satellites into information that can affect policy and information that can affect the design of future satellites to make sure we have the data that's needed for answering questions. The United States government operates what they call decadal surveys, which are key studies run by the national academies, which review what kind of systems should be designed to make the next generation of Earth observations by NASA, by our NOAA weather agency, by our United States Geological Survey, which does our land mapping. And so we have an ongoing cycle of improving that source, but they traditionally were not designed for operations and policy. They were designed more for scientific research. So my team often brings together scientific experts who can help us make models of what's happening in the environment by translating the scientific satellite data. But we also need economists and people who understand how to estimate the human impacts of this environmental change. So we make a vulnerability and social impact model. In my training in system engineering and technology policy, we can also ask, what does this all imply for policy options for decision makers? And in my training in system engineering, we can ask, what kind of mathematical model can we use to analyze the different options for how to design future satellites? So I've used this framework to guide implementing projects in places, and particularly I'll show in Ghana and Angola, but also other places around the world. And it allows us to ask, what can we learn from today's space technology, as well as what recommendations do we have for the future technology? Here's some examples of organizations and leadership teams that have invited me to work with them, applying that EVDT framework as part of using satellite data to answer policy questions. The Yurok tribe, for example, a Native American tribe in Northern California, we have a grant with NASA to work with them to map their forests because they are receiving carbon credits through the California carbon trading system, and they want to receive funds to help them buy back indigenous ancestral land that they value as holding as part of their ancestral territory. The city of Rio de Janeiro has been a great partner. We've been working with them on mapping both endangered mangrove forests, which are very important for climate management, as well as mapping greenhouse gas emissions from satellites. And I mentioned also the government leadership in both Angola and Ghana. These are examples of some of the collaborators we have, and I'll show more detail about those two projects now. Let's start with Angola. And you see here I'm pictured with Dr. Zolana Joao, who is the founding leader of the Angolan Space Agency. In Portuguese, it's called GGPEN, which means the National Management Office for the Space Program. And we can just celebrate their achievements. They've only been operating a little over a decade, and in that time, they've been able to procure a major communications satellite. The first one needed to be repaired, so they are actually on their second version, but it's working well. They're operating it nationally. They've developed a national satellite operations center. They're trying to make sure they can see the use of that system for those areas in the country that need communication services to be improved. And they're pursuing a future plan to have an Earth observation system of their own. And these are key steps, both in being able to kind of break open this black box of space technology and make sure those technologies are serving them. And they can combine their own satellites with other satellite services to get all the needs met. We have a project that's funded by NASA to work on applying NASA satellite data with our EVDT framework to address drought. And the proposal for the project came directly from Dr. Zolana and from the broader Angolan government. And I was kindly thankful to respond and to form a team and to apply to NASA for funding. So we do have funding for the US side from NASA, but I want to also give appreciation that the GGPIN team, the national agency in Angola, they're funding their own contribution. So you could say the two government agencies are each funding teams within their country, because that team has paid for so much travel and for their own staff time and coordination with other agencies in Angola. So just to emphasize, we often say it's a NASA-funded project, but it's really mutually funded by the two governments. Because of our work, Dr. Zolana and I have been able to share this cooperation and the model that we've used at a number of important venues. For example, the United States government hosted a key meeting with many African leaders visiting Washington, D.C. Several years ago, and Dr. Zolana was able to speak about our project there at the U.S. Africa Leaders Summit. We were also thankful in Angola to present the project together to the U.S. Secretary of State. As you can perhaps notice, the US government and the Angolan government are in a period of increasing their cooperation. And I'm thankful that to be in a position now to have a great scientific cooperation with the space agency. And it's been meaningful for us to present that as a great example to the US government. And we hope that they'll support more similar projects. In this case, we're presenting to Secretary of State Anthony Blinken, to the ambassador of the US to Angola, as well as to the Minister of Science and Technology from Angola. So in this project, we're customizing this EVDT framework, and we are showing that we can bring in NASA satellite data, make estimates of agricultural drought, and then understand the social and economic impact of that drought, and make maps of human vulnerability, which then influence the policies that are being considered. The policy organizations that address the drought in Angola are asking two kinds of questions. The first would be a short-term question. Where is there a need to deliver sort of short-term aids, making sure that people have access to food and water during drought periods? There's also questions around long-term changes. There's already the installation of pumping systems that can pump water from areas that are more abundant with water to areas that have less. And so we hope that the mapping we'll do will help guide their plans and also evaluate the impacts of these implementations. The areas in southern Angola, thinking of provinces like Cunene province and Namib and Wele province, they do experience ongoing cycles of both drought and flood. And I'd say, in a sense, our question is not so much asking, will there be drought? Because we can expect that to continue. There are ongoing issues with climate that kind of show this as a pattern. So the question becomes, for communities that are depending heavily on raising livestock, how can they continue in their livelihood if they're experiencing these heavy patterns of rainfall and drought? You see here a picture of some of the collaborators. I'm standing next to Josh Solana from the Space Agency, and many of the employees you see here are from the agency. But also next to me on the other side is one of the leaders of the emergency response team in Cunene, and you see other leaders from the Ministry of Water and Energy. I appreciate so much that the teams in Angola are cooperating closely so that the knowledge we gain through the space-related technology can be transferred to organizations that have responsibility for responding to the drought. This technology that we're using includes drawing from NASA's satellite technology called a system called SMAP. SMAP stands for the Soil Moisture Active Passive Satellite. I'm really pleased also in this case to collaborate with Professor Dara Ntakabi here at MIT. We are lucky at MIT to have leaders like Professor Ntakabi. He is actually the NASA science lead for the satellite called SMAP. So he's actually the world's leading expert on the science coming out of the satellite, which is just what we need to make sure we're translating the information correctly. And Professor Ntakabi advised us not just to use the publicly released data that NASA already provided about Angola from SMAP. Instead, we're carefully reanalyzing the data with local assumptions. And I think what we're seeing is that there's plenty of global data sets available that come from NASA data, but they're done with what we would call sort of global average estimate. When you look at just one country in detail, and you carefully consider the conditions there for their drought levels and their flood levels, you can get a more customized, relevant answer to what the drought levels are. And so it's important for us to go back and draw from the expertise of Professor Ntakabi and do fresh analysis that is not usually released by NASA, just for this country, and apply it also to other countries around Africa as well. So we have these newly developed estimates. What we're showing are actually drought indicators based on a well-established, at least in literature, an analysis of the drought. And it's customized to the area in Angola, where the lower yellow colors, those are showing areas of low drought, but the bright red colors like D4 and D3 are areas showing the amount of land area that's experiencing intense drought in those periods. And you can tell from the patterns, it's already evident just from the last 7 years that there's been a cycle of seasonal drought basically every year, and some years were particularly difficult. We're going to mix this information with socioeconomic composite indexes, and this is also a contribution because typically these are done at the national scale. We're doing it at the municipal scale. So we'll have data showing for small towns in Angola what their particular state is with regard to socioeconomic challenges or opportunities in the areas of social categories, demographic, agricultural access, economic activity, and health. Ideally, this means we can consider where is the drought and also where are the people who particularly need support and how are they also coping with the drought. Ultimately, it means we'll have pictures like these. There'll be a visual map of the drought. So on the left, you see the drought indices. And on the right, you see indices of the certain levels of vulnerability or benefits that that region has. So this is looking at all of Angola divided by municipalities, so it's smaller regions. And each one is shown in terms of its level of economic impact in that certain area. So things like water access and forest access can be opportunities. and population density and the level of different medical experiences can be important in understanding how they need to be supported to respond to the drought. This is just a mock-up, but eventually we'll have an information system. It'll be a website that shows more detail like these, and it'll be interactive, which will allow the team to be able to show this information to policymakers. And the team at GGPIN has the experience of building their own interactive websites that show this kind of data, so they're going to lead this process and with the support from the US team. Great, so that was our case study on using satellite data from the NASA SMAP satellite on the drought management in Angola. I'll briefly highlight the example of using EVDT to consider both biodiversity and land use change in Ghana, again hosted by the Ghana Space Science Technology Institute and also the Ghana Statistical Service. I think a great model that we see is the cooperation between the Space Agency and other socially driven agencies. I want to just give appreciation to those people who do census data collection all over Africa. I know the folks well in Ghana and in Angola. Angola, for example, is doing a really important digitalized census this year. It's going to be really revolutionizing the data they have about their communities. And that's going to give the governments the tools they need to better understand the community they're serving as a government. In Ghana, I was invited particularly by the Statistical Service and supported by the Space Agency to respond to questions of how they can best understand and support or respond to issues around mining. Of course, Ghana is endowed with important resources such as gold, and there's a tradition of artisanal mining, which is local scale mining, but sometimes also influenced by large equipment that is brought in by outside interests, which leads to deforestation and major water pollution. So the question can be, how can the government of Ghana respect the traditional rights of people who live on land to do local small-scale mining, but also consider what it means to support and to reduce the environmental hazards with large-scale mining that's unregulated, and then to support existing mines that do follow the Ghana Environmental Protection Agency requirements. So you see me here standing in front of an informal mine, and I'll tell you more about that story in a moment. It is another case where adapting the EVDT framework, we're considering the environmental changes, social and economic changes, as well as what it means for the country to monitor their deforestation using this technology. And we'll show how we can use satellite data both to estimate the state of forest and the new mines. There's a great paper also available. Happy to make this available to everyone as well. It's a paper where we've published our technique to use satellite data and machine learning to estimate the progression of mining in Ghana. And it's co-authored with several leaders from both the Ghana Space Science Technology Institute and the Ghana Statistical Service, as well as a US-based team. This project was also funded with support from NASA and in-kind support through the efforts of the Ghanaian organizations. One of the key results we share publicly is this map that's highlighting the land use change between 2015 and 2020. For example, it means we use satellite data in each of those years to look at what's happening in the different economic activity areas, including mining, but also looking at urbanization, looking at which areas are forested, which areas have different kinds of woody crop agriculture. Woody crops, as you may know, in Ghana are really key to the economy, whether it's cocoa or palm. There's a number of important crops that look like forests, but they are plantation-style trees, and since they're grown in rows. And so we can distinguish between those patterns and the more wild forest as different categories of crops using satellite data. And I think it's an important knowledge for the government to have and for organizations across Ghana to have how they're expanding or contracting those different categories of land use. We worked closely with the Ghana Space Science Technology Institute. You see me here with the director. I had a chance to interview them about how they used our results from the project of mapping mining into informing policymakers. And part of the trip I did recently in 2023 was to both compare our results from the satellite data, also with results that relate to what we see on the ground. And because the government has been working gradually to improve the safety in areas where there is mining, the team is able to take us out to go in a field drive and to see examples of mining in person. You also see my colleague Priscilla, who's one of our researchers here at MIT, and she's making sure that the code we developed to do the mining mapping is available to our team in Ghana, and we're even now continuing to have that transfer and comparison of methodologies. The team here at GSSTI is also very capable at making their own maps, and so we were comparing our two methodologies. We spend a lot of time both with coding together, but also with fieldwork together. And so it's also a chance for the two agencies on the statistical side and the space science side to work together. The Statistics Service took the lead for designing our trip. We took a drive from Ghana, starting in Accra, and went west over to Cape Coast, and then drove north up the Prof River and we were looking for the evidence of mining on water pollution. You see some of it here. Sometimes the waterways, even to the ocean. This is the exit of the water of a river going into the ocean. And in the background, it should be blue water, but it's actually been influenced by years of mining. And this yellow color is the result of the silt that's created, but also the chemicals that are used in the mining process. So we were affected by seeing how communities on the coastlines were experiencing the mining secondhand, but they're also experiencing erosion and challenges due to different strategies that are used by the civil engineers to reduce erosion in one area and often cause erosion in another area. So this colleague, this man who lives in the community here in one of the fishing villages, told the story of his whole lifetime in this village and of seeing actually the encroachment of the sea, where they used to have much more land there, but there's been a loss of land due to erosion, which is also a function of both climate change, but also the local policies for how they try to manage the erosion. We took the drive then going north of the river. You see my colleague there, Charles, who is our host from the Fiscal Service, highlighting this water pollution and how the color of the river is not its natural state. We can also see it in satellite imagery, noting that the river color does change over time due to effluents from the mining activity. So we come back eventually through our drive to visit this spot, and we're able to see that there's areas that could be woody crops. I mentioned, for example, the economic opportunity with things like rubber. This is a rubber plantation, and it means that they are tapping the trees and allowing the sap to form these small bowls of rubber that can be sold. But right next to this area, the area is being deforested, because the question might be, do you wait to gradually get the value from the rubber, or do you actually cut down the trees and make a path to an area for mining? So we saw this trade-off happening right before our eyes, an area that was already happening as an economic activity, but was being basically challenged. The decision was being made to consider mining it instead. And this is the kind of mining that's likely to be outside the regulations of the Environmental Protection Agency of Ghana, because it's large scale, it's deforesting, but it's not in a licensed category. We did have some time, though, to see some of the traditional forests that actually are part of a national park and to enjoy the conservation that's happening there. So, of course, the government of Ghana, as a sovereign country, needs to decide how they want to manage these land questions, but we're so proud to offer satellite data as a tool, because it's possible to get regular updates from year to year and see what's changing with this mining, with the use of woody crops, and with the conserved forests, to see how they're protecting their biodiversity and land use. I just want to close briefly with one more example. I gave a lot of examples of how these countries are using satellite data to map drought or forest, but I also just want to put an example of what I mentioned, which is the benefit of basic research. So maybe you can see I'm sitting here in a special place. I'm actually on top of a satellite dish as part of an overall facility. Here's the view. It's the Ghana Radio Astronomy Observatory. So as my closing thought, I just want to mention the contributions of Ghana and about 8 countries in Africa to the Square Kilometer Array. Whenever I go to Ghana to work on the project, I always ask if we can visit this telescope, which is a major radio astronomy telescope, which is the first operational contribution within the Square Kilometer Array Africa. Square Kilometer Array is an international venture to make a network of radio telescopes that will be located across Africa and also in Australia. They were competed through an international competition. A consortium of countries has formed this goal to have this major network. And South Africa led a team with 8 total countries in Africa. Countries like Kenya and Mauritius are also involved. So eventually there's going to be what they call a virtual baseline. Now, a baseline is the distance between the locations where you have radio telescopes. And the longer your baseline is, the more resolution you can get by using mathematical results of your observations in Kenya and in Ghana and in South Africa, and then making math to say, it's almost like simulating a telescope the size of all the continent of Africa, meaning you can mathematically argue that if you have a measurement in South Africa and one in Ghana and one in Kenya, it's as if you virtually have a dish that's the size of the whole continent based on the distance between those baselines, or the distance between those observations. The thing they need to do is install atomic clocks so that at each location you have a very precise estimate of the time. And that's needed to make sure you can make the combination of what they call interfering signal from the different telescopes. But I was so proud because the Ghanaian team, they rebuilt what was already existing as an old system that was used for satellite Earth communication. So this used to be a dish used to talk to satellites and have communication systems. But it was re-engineered so that it can also move across the sky. It can turn around its axis, and it can also turn its face to different directions. That's what you need to become a radio telescope. So this is the first operational piece of the Square Kilometer Array, along with a demonstration system called Meerkat in South Africa. And more is coming. And whenever I go, they always have youth there who are learning about radio observatories, and space technology. So I'm so proud to collaborate with these key leaders in Ghana and Angola, and I hope you'll have a good discussion with me about the future that's happening within this emerging space industry across Africa. Thank you so much.
All right. All right. Thank you so much, Danielle. Wonderful. For anyone who doesn't know, I'm Ari. I'm leading the MIT Africa or MISTI program, and a co-host of this event with the Alumni Association. So please feel free to put your questions in the chat, and I'll relay them to Danielle. And I guess I just wanted to start by saying that I love how your personal experience and that you shared it, and also the work that you're doing now, I really feel like highlights the way MIT really hopes to engage across the African continent, in the sense that core strengths, core capacities in research, education, and innovation, like that's really where we want to collaborate. We can find partners really in any field of study. It's just a matter of looking. And just thanks so much for sharing that experience. I also have, this is just a side note, I've lived in Oloktok for a few months, and so yeah, in Kenya. So I was very pleased to see that you have experience living there. It's not a place I hear about too often. So please add your questions, but I will take the first one now from Keith. So while you were speaking, the U.S. Embassy in Nairobi released the warning below about severe weather alerts. How is space technology part of these early warning efforts? I think we've seen on the news, we've seen some of these disasters taking place recently in Kenya there was a dam washing out, a lot of destruction. How are people using these technologies to benefit in that sense?
Thank you so much, Keith. A very relevant question and appreciation to Ari. I'll just think about what Ari was saying. It's in fact directly the point, meaning I was an MIT study undergraduate, and I was afraid that maybe I have to sort of quit being an engineer to then have, a meaningful sort of cooperation with Africa. But that's actually the opposite, right? As you said, the point is that, of course, I can then engage with the technical leaders once I knew who they were, especially first in Kenya and then later in other places. So maybe Kenya is a great place to start, because maybe I want to give even further appreciation. As part of my doctoral studies, I visited the technical leaders in Kenya. I had gone previously to work in a school, right? So I was just meeting kids. But when I came back in 2010, I met with leaders who were part of forming what's now the Kenya Space Agency. And back then, there was a consortium of organizations that were helping to incubate the space program. But there was already, and there continues to be, really strong expertise in Kenya for using satellite remote sensing data. It's really a regional and international leader in this area. The national government has a Department for Remote Sensing and Resource Survey. But also, there's a regional center for the mapping of resources for the development, and both players, serve their different constituencies very well. And I want to appreciate opportunities I have. I was thankful to recently be at this New Space Africa meeting, and I asked for meetings, particularly with the directors general of the various space agencies that I know really well, especially Kenya, South Africa, Angola, and Ghana. And actually, there was a team also from Malawi that was so sort of eager and excited that I talked to them too, and also discussed ways for cooperation. And actually, out of that set of meetings came a proposal that responds to the question from Keith. We are writing a proposal that I hope might be funded, but I think it leaves a foundation either way. We're seeking funding from the National Science Foundation to work together on using satellite data to respond to flooding. Because what I noticed also is that every region in Africa experiences flooding. Really, it's a global phenomenon. If you ask which particular natural disasters or hazards does each region experience, there'll be different local ones. But flooding is common across basically everywhere, and at least in some seasons. There already are, for example, in my own NASA experience, there's interesting things that happen. NASA has a team within their Earth Science division that addresses disasters, and actually when events like this happen, they go into action and they start to organize how NASA data could be used to support the response to things like flooding. And what I notice is there's a possible gap in terms of making sure that during these periods of urgency, that they actually know who to share with who lives in Kenya. And they work with the embassies, they work directly from the formal government channels. But what my proposal offers is a chance to have, during times not of disaster, during times of more focused academic studying, to build relationships between the technical leaders, say at NASA, who are doing disaster response, and those in Kenya, South Africa, Ghana. And so my proposal is that we prepare in advance the technical dialogue so we have the tools to work together so that when the disasters come, we're better prepared.
Okay, thank you. I have a bit of a question. I just wanted to jump in quickly and maybe reserve the right as a co-host.
Yes.
I know when it comes to environmental monitoring, there's been a lot of innovation in the use of drone and drone technology in many African countries. Of course, like lower cost, lower barriers to entry. I'm curious if you could just comment on the trade-offs between the two. How is one better for one versus the other? Just comment on that.
Yeah, I'd love to talk about the work, the options. So I'll say I'm interested in Earth observation for the use of people in Africa who want to manage a company or serve in a government agency. And Earth observation doesn't have to be from space, although my particular training is in satellite design. I love satellites, and that's great. And I think many countries are asking how they can include that in their portfolio. But Earth observation actually means measurements you can take from different places, sensors that might be in water or in the ground or in the air or in space could all be used. And they each have different pros and cons. My own personal story of trying to test out their benefits. We were studying a lake in West Africa, and we wanted to do monitoring of invasive plants. And the lake is medium size. It's not like Lake Victoria. It's Lake Nokwe in Benin. It's medium size. I can cross it in a slow boat in 8 hours, or you can go faster if you have a bigger motor. But we tried to take a drone there, and we realized, well, it could be good if you really know where you need to go. But for example, it's not useful to get the entire lake area or even major river sections of the lake because of winds, because of the limitations of the batteries, and because you actually, just the overall flight speed of a sort of commercial off-the-shelf drone wouldn't be very effective. A larger plane actually would be. So even depending on what questions you need to ask, different services will help. If you need to do something routinely, if you want an update every 2 weeks, a satellite might be better because it actually does pass over most satellites, depending on their orbits and the particular dynamics, pass over most places on Earth at least every 2 weeks. If you have a constellation, maybe more often. If you need to get a very particular high resolution measurement or even another service like delivery that's not as frequent but it needs to be done really well, sometimes a drone's a better option. But I don't think either one's necessarily quote unquote cheaper in the overall cost, meaning the question is, what are you paying for? It's like, do you need to pay for the vehicle? Do you need to pay for just the data service? Do you need to pay for transport of somebody from where they are to come to where you are to do the drone acquisition? And then who's doing the data analysis? There's cost at every stage. So I think one has to look at each case. In our case, we found it harder than we thought to use drones, but of course we hope for more local innovative companies that can provide services so that the colleagues I work with and the different government teams can sort of request their specialized service, and maybe it's cheaper when you spread that kind of cost around. Yeah, thank you.
That's a great segue to the next question, which is, well, how would you advise maybe a young graduate living in an African country who's interested in opportunities or pursuing opportunities in this sort of space-enabled space?
Yes, indeed.
Yeah.
He was chosen on purpose. I'd love to give advice because I think every time I go to Angola, it's great that the space agency organizes a big event. They get at least 100 youth who are high school and college to come, and they sit so quietly. I'll give them a talk like I just gave you, and they sit totally quietly. And as soon as I finish, they have like 15 questions. They've all written their questions down, and they're ready to come take selfies. It's really awesome. And so I'm looking at them thinking, wow, like what a rich legacy of all these young people who are smart. Their questions are always super organized, and they've thought a lot about what I'm going to say. They've looked me up before I showed up. They've organized and translated the question from Portuguese to English. It's awesome. So I'm thinking, what can they do next, right? There's only so many that will get government jobs, and then there's a question of private opportunities. Now, there's a couple of angles. Those who are interested in software can start to figure out how to make value-added services using technology from space that are software-oriented. For example, taking existing data sets and then turning them into information for a particular sector, whether it's mining, whether it's greenhouse gas emissions, whether it's helping organizations track their facilities. I have a wonderful example of a colleague from Indonesia who did the master's with me at MIT. This is Aji Kishio. We studied examples of satellite-based Internet of Things systems, and he went back home to Indonesia and started a great company called Netra. And he's thinking about how his country is an archipelago of islands, and many companies have distant locations where they're operating facilities. So he helps companies put instruments and communication systems on remote facilities. It could be boats, it could be a forested area, it could be facilities like cars and tractors. So he found a way to use space technology and find companies that have money that need services in his context that fit his need. I think we need that same kind of model, and it can be with low capital at first if it's software oriented. And then if you get some more capital, you can have hardware activities as well. But they have to be customized to the industries and the types of needs that are relevant, both to companies and the government in your country.
All right. So I think we will start wrapping up. So thank you so much. Oh, did we get another question? Okay. We have one more question before we wrap up. We have a few more minutes. How can alumni be supportive of your work? There's a question from Samuel. Thank you so much.
Yes, I really appreciate that. I'm going to say something that may sound, I don't know, oversimplified, but I want to highlight there's two opportunities. Maybe one is just spread the word among your networks that like there's great things happening among both private and public entities in Africa in the space field. I often ask people like, do you know that your government has a space program? If you're from Angola or Ghana or Nigeria or Rwanda or Mauritius, like you do. So just spread the word that there's interesting things. You may have critiques of your own government, which is fine, but spread the word about positive things that happen, especially in the space industry and technology industries. And number two, I hope in the future to do more cooperation with African universities and to spread. We have a program that teaches students to make programming for robots. And I'm looking for fundraising ideas, especially to serve the African community. And I hope that that can be an opportunity to have a way to link between MIT, African space agencies, and then African universities and youth. So in the future, I'm open for ideas about that. I think it's an opportunity for us to cooperate. Thank you.
All right. Well, thank you so much. I'll clap on behalf of the others. We really appreciate you taking the time out of your schedule to give us this fantastic talk and share about your experience and what you're working on. Thanks to the Alumni Association for hosting, all of our other partners for coming, for the alumni for being active participants. And we hope to see you again next week with Professor Mavunga on the possibilities for future engagement between MIT and Africa, sort of a really nice place to end. So thanks again, same time, same place next week. Everyone have a wonderful week and weekend, and we'll see you later.
Thank you so much.
Thank you.
Thank you. Cheers.